Okay, students. So now you are in part 5 of time series analysis video. So it's bit of, as I told you earlier, also this is bit of a lengthy lesson. So there are so many steps, so you have to follow them in a sequential manner. Now we are in step 10. So in step 10, we have already followed the step 10 when it comes to the practice question. So we have deseasonalized the data set. So in order to deseasonalize the data set, what we did was we have divided the cells with the seasonal component that we have derived. So now if you have been following the steps along with me, now you would have you would be having Excel, you would be having an Excel like this. Check whether you are getting this particular Excel. Okay, so now we are here. So the next step is, now we have derived, we have the seasonal component, we have got rid of the regularity. Now we are left with only the trend, because according to the, we have been following the multiplicative model. So I'm going to subscript it. So T. Okay, so according to the multiplicative model, y equals s into I into t. The reason is because we don't have any cyclical factors, because we have only the data for a limited time period, only for 4 years. So we have been following the multiplicative model. We have got rid of the regularity factor and we have derived the seasonality, and now we have to come up with the trend component. So I subscript it. So this t, the subscript t, here also you have a subscript t that represents basically, here in the second step I told you to come up with the time code column. So by now, if you have been following the video, you should have derived, you should be having this column also. So if you have missed taking this column, now you can insert a new column and have your time codes like this. So now all cool. Now in order to derive the trend component, we are going to run a simple linear regression, taking deseasonalize this data set as our y and taking this particular time codes as our x. So how can you run a simple regression? So I told you, we have already discussed as to how you can run a simple regression when it comes to Excel. So first you have to make this data analysis tool pack. On data menu, you have it on the right hand side, but this is not readily available. Make sure you enable it. Go to options, add-ins, and here you have to choose the Excel add-ins. Go, and here you can choose the data analysis tool pack. Since I have already made it available, I can see the data analysis tool pack on my data menu. So now I'm going to run a simple regression. Go to regression. So here I asked you to take this as your input y range. So I'm selecting it along with the label. So the input x range is this. Since I have selected, for both x and y, when I was selecting both x and y ranges, I have selected the label. So I'm choosing labels. Now I am going to select the output range. That means where do I want the regression output. So I'm going to have it somewhere over here, so that it won't be coming along with the data points that are already there. So I'm going to have my output over here. When I click OK, so now I have my regression output. Look at my regression output. So this is my regression output. So when you look at a regression, these are the key things that you have to look into. So normally we look at the r squared value. That means to which extent x variable is explaining the variation in the y variable. So it's cool. It's 91.51%. And the significance of the model is also okay because it's below 0.05. And when we look at the intercept and the p-value for the time code which we have taken as our x variable, the coefficient, so that also below 0.05, so that everything seems significant, model and the coefficient. So now we are going to run the regression over here. So equal, I'm going to come up with the regression model. Intercept is 5.05. So that's there in B442. So I'm going to, in my model, I have to make it a constant. So highlight it and click F4, or else you can put dollar marks at the beginning of the letter B and digit 42. So then plus, what is the coefficient? Here the coefficient you can see it's 0.14. So it's a positive coefficient. So this seems to be correct because when it comes to uh, here the trend line, it's more of a the trend line over there. Okay, so now we have derived the regression output. Now I'm going to come up with the regression model here. It's equal. So what is the intercept? It's 5.09. So when I choose it, I'm getting the formula, the cell reference. So I'm going to make it constant. Otherwise, when I drag it down, the uh, cell reference might change. And plus, what is the coefficient? It's 0.14. That also I'm going to make it a constant. So plus, okay, this one also constant. Okay, into what is our independent variable? We have run the regression considering t as our x variable. So here, and so now we are done with the trend component. Also, I'm going to have it in the two decimal places. When you look at this regression model, since the you have got the coefficient for the time code as 0.14, it's positive. So when you look at the sorry, when you look at the chart, look at here the baseline, you all can see there is a positive slope. So that is further proved through the regression model, that regression output that we have derived also, since it seems to be a positive coefficient. I hope what we have done until here is clear for everyone. Okay, I hope what we have done until now was clear for you. Now we are going to forecast the future based on what we have been doing until now. We have been doing a lot of work, so now it's time for us to forecast. So here in this point, what we actually did was we took out the seasonality and irregularity component, and here we have come up with the seasonality component, and here we have the trend component. So based on the multiplicative models, now we have got rid of this irregularity component, because irregularity component is different from one point to another in the real life situation. So here now to forecast, what you have to do is that you are going to multiply the seasonality by the trend component. So when you do that, you are getting the result. So these are the forecasted values. If we had forecasted based on this particular method, for year 1, quarter 1, we would have got the forecasted value here as 4.89, but in the real life situation it has been 4.8. So when it comes to forecast is about future. So in what you have to do, what the intended objective is to forecast the sales values for the next four quarters in year 5. Year 5, let's have year 5. 1, 2, 3, 4. Okay, so here we'll drag this down. So now we have everything we need, and we'll drag this down also, because here we have derived this trend component based on the simple linear regression model. So when you drag it down, since we have entered the time code here, now you would be automatically getting the seasonality and trend components with respected to year 5 4 quarters. Now you can forecast the values, can't you? Now when you drag this down, you are getting the forecasted car sales for year 5. See how nice is that? So these are the forecasted values. So from here onwards, we have been doing so much of calculation, so much of steps, so much of logic that we have carried out in order to forecast the car sales for the next year for all 4 quarters. Is it understood? But it's not yet over. Now we are going to graphically illustrate in the same chart that this particular forecasted values also we are going to have it plotted in the same time series plot of sales. Okay. Okay, now we are going to graphically plot the forecasted values into the same time series plot of sales. Plot of sales. We'll see how it goes. So in order to plot this particular forecasted values in the same chart, go to add year cast. Here you have to choose the forecasted values. We are not going to select until here, but also year 5 4 quarters also we are going to select. Now we will click OK and OK. So can you all see? Look at the graph now. So here, if you want to have the year 5, also year 5 with all 5 quarters, you can always go to year and here edit. You can choose until year 5. Now all cool. Okay, look at this graph. So this orange line was the original sales, and this is the line in gray is our forecasted value. So if we had not been using the mathematical operation over here, if we had followed the same graph like this, so we would still have forecasted the values. But since we have followed a mathematical very logical process, now the forecasted values are very accurate. So it's very clear that these real values has been very close to the forecasted values. So that's the end. We now you know how to forecast. So for year 5, all 4 quarters we have forecasted. So just recall what we have been doing so far. So the first step was to we have come up with the time series plot of sales. We have visualized the data set. Then after that we have smoothened the data set. We in order to smoothen the data set, we have followed this technique called moving averages technique. Since we have considered 4, it's 4, the 4 quarters were there now. So since we have considered 4, it's an even number, so we had to again derive the centered moving averages. After that we have taken out the seasonality and irregularity out of the sales. So you should know what each of these figures means. You should know how to interpret them, and then we have derived the seasonality. Then we have deseasonalized the data set. After that, based on the regression output, we have come up with the trend component, and based on that, we have forecasted the values by multiplying seasonality into trend. After that, we have again plotted the forecasted values to see how accurate is our forecasted values are. So I hope what we have done is clear for you. So if you are not clear about any point, you can always uh, replay the video and practice this question more often. Again, I have given you another question, so make sure. So there's an homework for you all, so you have to do this particular question and practice, because we never I'm planning to give this one of as one of your final exam questions also. So please practice makes you perfect. Thank you.